Imagine waking up tomorrow, looking out your window, and seeing a mammoth walking down the street. Sounds like something straight out of a movie, right? Except there's a company in the United States working on making part of that idea a reality. And no, this isn't some crazy startup working out of a garage. It's a biotechnology company that has already raised more than $600 million. And one of its founders is George Church, a geneticist from Harvard. And their plan is much bigger than simply creating an animal that looks like a mammoth. They want to create an elephant genetically modified to have the traits that allowed mammoths to survive in freezing environments. And that raises the question I want to investigate today. If we can bring an extinct animal back, should we? I started this case with a very simple question. What does it actually mean to bring an extinct animal back? Because when you hear that phrase, you probably imagine something very specific. A frozen mammoth, a machine, a laboratory, some crazy technology. And then, the animal walks out of a chamber. But that's not how this works. The company is called Colossal Biosciences. It was founded in 2021 by Ben Lamb and George Church, and one of its biggest projects is the woolly mammoth. And the interesting part is that they're not simply trying to clone a frozen mammoth. They know that's not how this works. Instead, they're taking the Asian elephant, one of the mammoth's closest living relatives, and trying to modify parts of its DNA to recreate traits that helped mammoths survive in extreme cold. Long hair, more body fat, changes in metabolism, traits associated with cold resistance. In other words, they're not trying to bring back the exact same animal that walked the earth thousands of years ago. They're trying to create an elephant with the key biological characteristics of a mammoth, and that completely changes the story. Because if you can modify a living animal to have characteristics from an extinct species, the question stops being, can we clone a mammoth? And becomes, how far can we redesign an animal? And that's where I found the first really interesting clue in this case. In 2025, Colossal introduced what it called woolly mice. These were genetically modified mice designed to display traits associated with the woolly mammoth, including longer hair and changes related to fat metabolism. Researchers made multiple genetic edits and used the mice as a model to test whether certain modifications produced the desired effects before attempting anything nearly as complicated as modifying an elephant. Now think about that for a second. A mouse might seem like a tiny, almost ridiculous part of this story, but it solves a massive problem. An elephant's pregnancy lasts around 22 months. A mouse's pregnancy lasts roughly 20 days. If you want to test dozens of genetic combinations, you can't wait almost 2 years every time you want to find out whether something worked. So you start small, test it in mice, study the results, make adjustments, test again, and only then start applying what you've learned to elephant cells. Colossal says its mammoth program has continued advancing, and the company's stated goal has been to produce the first mammoth-like elephant calves around 2028. And this is where the case starts getting really strange. Because the animal that could be born in 2028 won't actually be a mammoth. It would be an animal created from a modern elephant, with genetic modifications designed to reproduce traits associated with the mammoth. And something similar has already happened in another project from the same company. In 2025, Colossal announced the birth of animals it called dire wolves. The animals were created using cells from gray wolves that had been genetically modified. The company made 20 genetic edits across 14 regions of the genome. But there's an important detail. These animals are not genetically identical to the dire wolves that disappeared thousands of years ago. And that's not simply an outside criticism. The science behind the project itself recognizes how difficult it is to reconstruct an extinct organism exactly as it once existed. Some scientists argue that what we're seeing shouldn't really be called de-extinction at all. Instead, it's more accurate to describe it as creating a genetically modified animal with characteristics associated with an extinct species. And that leads us to a question that sounds like semantics, but really isn't. if you modify a wolf so that it looks and functions in some ways like a dire wolf, did you bring the dire wolf back, or did you create something new? Because depending on the answer, the entire meaning of this project changes. But let's assume the technology works. Let's assume that a few years from now, there is an animal with characteristics very similar to a woolly mammoth. What do we do with it? Because creating the animal isn't enough. Eventually, the goal would be for these animals to live in environments similar to those where mammoths once lived. And that's where the second problem appears: the ecosystem. The mammoth disappeared thousands of years ago. And during all that time, the planet changed. The climate changed, plants changed, other animals changed, and ecosystems reorganized themselves without the mammoth. So imagine taking an animal that has been gone from that environment for thousands of years and simply putting it back. What happens? Maybe it helps the ecosystem. That's actually one of the ideas behind the project. The argument is that large herbivores could alter Arctic landscapes by knocking down trees, opening areas of vegetation, and compacting snow. Those changes could potentially help keep the ground frozen and contribute to preserving permafrost. It sounds incredible. An extinct animal helping fight a modern environmental problem. But there's a word that keeps coming up whenever scientists discuss interventions on this scale: uncertainty. Because an ecosystem isn't a machine with a handful of parts. It's an enormous network. Change one thing, and you can change many others. The animal could compete for food. It could alter vegetation. It could change the behavior of other species. It could transport microorganisms. It could modify the soil. And maybe something happens that nobody predicted. That's the problem. We're not simply bringing an animal back. We're introducing a new variable into a system that has spent thousands of years evolving without it. And there's another problem that's even harder to ignore: disease. An engineered animal would be born into a world completely different from the one its ancestors lived in. Its immune system would have to deal with modern microorganisms. And there's another possibility. What happens if an animal created to reproduce traits from an extinct species carries or develops something that affects modern animals? Maybe nothing happens. Maybe there are consequences. And the truth is, we don't know. Now there's a third problem. And honestly, this one is even harder for me to ignore: the mother. Because a mammoth doesn't come out of a machine. It needs a pregnancy. And one possibility involves elephants, including Asian elephants, which are already endangered. Think about the irony. You're trying to bring an extinct animal back, using a species that is still struggling to survive. And that's exactly why artificial womb technology has become such an important part of this project. Colossal is developing systems that could potentially allow embryos to develop outside an animal's body. And now, the case becomes even bigger. Because if that technology actually works, it won't just be useful for mammoths. It could have applications in animal reproduction, conservation, and potentially other areas of reproductive medicine. Think about what just happened. The project started with a question that almost sounds ridiculous. Can we bring a mammoth back? But in trying to answer that question, scientists are developing technologies that could have consequences far beyond the mammoth itself. And there's another issue: the money. Colossal has already raised more than $600 million in funding. That's a huge amount of money. And that's where one of the biggest debates surrounding de-extinction begins. If we have hundreds of millions of dollars to invest in genetics, conservation, and biotechnology, should some of that money be spent trying to bring extinct animals back? Or should we use those resources to save species that are still alive? Because think about it. Every day, species are being threatened by habitat destruction, hunting, climate change, and other human activities. Those animals don't need to be resurrected. They need to be protected. So there's a pretty strong argument that every dollar spent trying to bring back a mammoth could instead be used to prevent another species from disappearing. But there's another side to this. Maybe the technology developed through de-extinction could actually help save living species. Colossal itself points to elephant conservation as one of the potential applications of this work. And maybe that's the most interesting part of the entire story, because perhaps the real legacy of a de-extinction project won't be the extinct animal. Maybe it will be the technology created while trying to bring it back. And that completely changes the question. Maybe the question isn't simply, can we bring the mammoth back? Maybe it's, what do we need to learn to make sure the next animals don't disappear? And then I reached the final part of my investigation. The idea that extinction might no longer be permanent, because that could change the way we think about conservation. If people start believing that an extinct species can simply be brought back in the future, there's a risk. Extinction might stop feeling like a permanent consequence, and that could be dangerous. Because protecting a species means protecting a real population, living right now, inside a real ecosystem. It doesn't mean storing some DNA sequences and hoping someone can reconstruct the species 100 years from now. And maybe that's the biggest irony of this entire story. We're developing technology to try to reverse one of the most irreversible consequences of human activity. But maybe the greatest value of that technology is teaching us how to make sure we never need it. So I come back to the question that started this investigation. If you could look out your window tomorrow and see a mammoth walking down the street, would you be amazed or would you be worried? Because maybe the real mystery isn't whether humanity can bring an extinct animal back. Maybe the real mystery is whether we're smart enough to know when we should. And now I want to know what you think. If the technology works, would you bring the mammoth back? Or do you think some things, once nature has closed the door, should stay in the past? And more importantly, if you could choose just one extinct animal to bring back to Earth, which one would it be? I'm already reading the comments. Maboy is closing the case, but the question is still open.